Alright folks, in this video we're discussing the negative sign. Having already discussed the operation of the negative sign under the mathematical functions, the mathematical procedures of multiplication, division, addition, and subtraction, we are now going to add another procedure, another operation to the list, and that is the operation of exponentiation. Right? Exponentiation, meaning we're dealing with exponents, we're dealing with powers. Right? So exponentiation will be E-X-P-O-N, exponent I-A-T-I-O-N, as opposed to multiplication. What is an example of exponentiation? Multiplication, 2 multiplied by 3 is equal to 6. 2 to the power of 3 is equal to 8. Sorry, 2 to the power of 3 is equal to 2 by 2 by 2, which is then equal to 8. Alright? I have a whole video on that, so I'm not going to take time to explain that in any further detail here. But unlike the previous video, where we only dealt with positive numbers, in this video we're going to deal with negative numbers under the operation of exponentiation, and we're going to examine a couple special relationships that you need to be aware of when you're dealing with exponentiation powers. Let us start using the exponentiation that we are most familiar with, which is squares. Right? Squares and square roots. 1 by 1 is 1, 2 by 2 is 4, 3 by 3 is 9, 4 by 4 is 16, 5 by 5 is 25, 6 by 6 is 36, 7 by 7 is 49, etc., etc., etc. 15 by 15, 225, 18 by 18, 324, 25 by 25, 625, etc., etc. Alright? So we are familiar to some extent with squares, and of course, by extension, with square roots. That is where positive numbers are concerned. What about when you have negative numbers? Because we are now familiar with the mathematical rules governing multiplication involving negative numbers, we can say with confidence that, let me use some small numbers to begin with. We can say that minus 2 by minus 2 is equal to plus 4. See what happened there? So two negative numbers multiplied by each other will give you a positive number. So it is not just a case where 2 by 2 is 4, which we're already familiar with, and which we can easily visualize physically. We could take 2 and we multiply by 2 and we get 4. We could demonstrate that physically. Not so easy to physically demonstrate, however, is the negative counterpart, where minus 2 by minus 2 is equal to the same 4. And that is where we start to get into some level of difficulty or uncertainty. Because being the human beings that we are, a lot of how we understand, in fact, most of how we understand the natural world around us is through our sensory perception. So anytime we have a situation where we can't see something, we can't touch it, we have to imagine now. It's a little tricky, and that is where sometimes you just have to take the rule as given. So normally we would just say minus by minus is a plus. We went to excruciating lengths to try to explain that. It was kind of tricky, but we try. Right? So we are applying that rule now to the subject of squares when you're squaring a negative number. Because in the same way that you could multiply 3 by 3 to get 9, a positive by a positive is a positive. If for whatever reason we find ourselves having to multiply minus 3 by minus 3, we know from our knowledge of the rules of multiplying negative numbers that the answer will be positive 9. Right? So that is something that we also have to be aware of when we're dealing with squares and square roots. Squares and square roots are not just for positive integers only, or positive numbers, or positive quantities. It is equally valid when the quantities under discussion are negative. And we have to be aware of that. What that means is that when we have to consider the square root of a positive entity, we no longer have the liberty of limiting ourselves only to the positive answer. Right? So, let me do a couple examples. We know that 8 by 8 is 64. Yeah, we know that because we know our squares and square roots, not so? Yeah? 8 by 8 is 64. Or let me say 8 by 8 is equal to 64. The corollary. I'm sure I used that word somewhere, and I explained it somewhere, and it's in TikTok somewhere. So I will leave it out. In fact, let me do it quick. The corollary. Listen now, man. Vocabulary is nice, you know. And the more you integrate vocabulary with your maths, you find that it makes the process enjoyable, and it enhances your understanding, because sometimes the vocabulary itself tells you what it is you need to know. So the corollary, C-O-R-O. Well, again, vocabulary in a maths class, boy. Well, I couldn't want it better than that, eh? The corollary means a proposition that follows from and is often appended to one already proved. Right? So in other words, if we know that 8 by 8 is 64, in other words, 8 squared is equal to 64, then it follows from that, or we could say that the corollary of that is that the square root of 64 is equal to 8. We know that too. Squares and square roots. 8 squared of 64 means that the square root of 64 is 8. But now that we're getting deeper into the negative numbers and thing, and we're multiplying the negative numbers, we also know that minus 8 by minus 8 is also 64. Same 64. So in other words, in consideration of the square root of 64, it is no longer sufficient to just list 8 as your answer. You also have to consider the fact, and I'm putting it in green, no, I'm putting it in red. You also have to consider the fact that because of this relationship here, what that means therefore is that the square root of 64 is also minus 8. You see? So, as far as natural numbers are concerned, that is, natural numbers being the numbers that you could physically count. 1 marker, 2 markers, 3 markers, 4 markers, 5 markers. Yeah? As far as natural numbers are concerned, the square root of 64 is 8. Because we can multiply 8 of one thing by 8 of the another 8 of the same thing to get 64 of the same thing. So to work backwards now, the square root of 64 is 8. But we ain't stopped there. We had to know now that because minus 8 by minus 8 is 64, we also have to consider that the square root of 64 is also minus 8, which means that whenever we consider in the square root, we have to consider the negative root as well. Right? So, to expand on the concept, instead of saying simply that the square root of 64 is 8, we could now say that the square root of 64 is equal to plus or minus 8. Much more complete than just saying the square root of 64 is 8. And indeed, depending on the topic or the circumstance in which you find yourself mathematically, there are situations where failing to consider the negative 8 will put you in hot water mathematically. Right? There are certain circumstances where if you only consider the positive square root, you will have an incomplete consideration of the situation. You must consider the negative root. And yet there are other circumstances where you have to ignore the negative root because of the physical nature of what you're dealing with. That is something that you will encounter on a topic by topic basis. I'm not going to try to explain that in any more detail here in this video. Alright? So, just to repeat, in absolute terms, the square root of 64 is plus or minus 8. There are some circumstances where you have to consider both the plus 8 and the minus 8. There are other circumstances where you might have to ignore the minus 8. And in fact, there may be circumstances too where the plus 8 is the one that you're ignoring. That's how maths is. Right? But once we start off from the point of view of the knowledge, we could then apply that knowledge in different situations that we encounter. So in other words, you have the knowledge and then you have the understanding of how to apply the knowledge, when to use the knowledge, if to use the knowledge, how much of the knowledge to use. Right? That is the difference between knowledge and understanding. Right? And of course, wisdom is a slightly different thing. I wonder if we could apply wisdom here, boy. Wisdom might simply be having the presence of mind to know that you had to be aware of the negative sign. So you have wisdom to know that you have to acquire the knowledge, and then having acquired the knowledge, you then have to invoke some understanding of how to apply and to use the knowledge. Boom! Alright? Nice. So, quick examples. Square root of 121 plus or minus 11. The square root of 100 plus or minus 10. The square root of 256 plus or minus 16. The square root of 289 plus or minus 17. The square root of 169 plus or minus 13. The square root of 4 plus or minus 2. The square root of 36 plus or minus 6. Etc. 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 Alright? So, we're getting deeper into this thing. The negative sign. Serious business. Right? So we're going to move on now from just powers of 2. And we're going to extend the discussion now. Because once we understand that minus, let me go back to 2. In fact, yeah, let me go with 2. Because 2 is a number that everybody familiar with. Right? And once we demonstrate with 2 as the base, real vocabulary there, boy. I'll leave that one alone for now. Once we demonstrate it with 2 as the base, we can deal with minus 2 as the base now. And we can extend the discussion. Quick note for those of us who are wondering, how come he didn't ask what is the square root of minus 64? We will leave that alone for now, right? We know that the square root of 64 is plus or minus 8. So you might be tempted to ask, well, if the square root of 64 is plus or minus 8, what is the square root of minus 64? We'll leave that alone for now. Suffice it to say that the answer to this is what we refer to as imaginary numbers. Alright? The answer to this, which is the one that we just discussed, would be real numbers. Right? And the two numbers being real, the plus 8 would be real and natural. The minus 8 would just be real, it's not natural. Yeah, it has plenty of things we could talk about, and I like to give the details. That is why I'm recording it using the available technologies, because you see how deep we go into this. We say it once and we're done. And a multiplicity of humans could ingest the information over a protracted period of time. Right, so forget that for now. You could check it out if you want. We have Google, we have books, we have other humans, right? So, let me go a little further now with this thing that we call an exponentiation, right? And again, we're going back to the, we're going to do this using the foundation that we already laid, where the multiplication of negative numbers is concerned, because remember, exponentiation is a process of repeated multiplication, which I explained in my other video where I discussed the difference between multiplication and exponentiation. But exponentiation is repeated multiplication, right? So in the same way that 2 to the power of 3 is 2 by 2 by 2, which is equal to 8. 2 to the power, sorry, there's a horse of a totally different color there. 2 to the power minus 3. We ain't even going there in this video. However, I have a whole playlist on indices, and I have a whole video inside there where we discuss the negative power, right? What we want is the negative base, not the negative power. Minus 2 is the base. Minus 2 to the power of 3, we apply the same logic here. Would be, watch it now, minus 2 multiplied by minus 2 multiplied by minus 2. Here's where the things that get nice, spicy, right? So we know that minus 2 by minus 2 is 4, right? A minus by a minus is a plus. We know that. The thing is, when you know that, you could apply the rules confidently to solve whatever situation that you happen to be in. So if minus 2 by minus 2 is 4, then this would be 4 multiplied by minus 2. You see what happening there? And 4 by minus 2, we know that positive by negative is negative. We discussed that too. 4 by minus 2 is minus 8. And let me go even further now. If we want to discuss minus 2 to the power of 4, watch it now. In the same way that we know that 2 to the power of 4 is 2 by 2 by 2 by 2, which is equal to 16. 2 to the power minus 4, sorry, minus 2 to the power of 4, you see? I say the wrong thing and I write the correct thing. Minus 2 to the power of 4 would be minus 2 by minus 2 by minus 2, by minus 2. Minus 2 by minus 2 is 4. 4 by minus 2 is minus 8. Minus 8 by minus 2 will be plus 16. Right? Or we could have said that minus 2 by minus 2 here is 4. Minus 2 by minus 2 is plus 4. 4 by 4 is 16. So in other words, minus 2 to the power of 3 is minus 8. Minus 2 to the power of 4 is plus 16. And if you keep that line of argument going, you would find that there are times when the power of a negative base is positive. Talking positive powers here now, right? We'll find that the positive power of a negative base is positive, and we will find that the positive power of a negative base at other times would be negative. Which then begs the question, how do we differentiate between a circumstance where the power is, where the answer is negative or positive? So in other words, do I have to go through this whole lengthy process if instead of 3 I had minus 2 to the power 9? Can I look at that and know whether the answer will be positive or negative? Or if I had, instead of minus 2 to the power of 4 on this side, let us say, for the sake of argument, that instead of minus 2 to the power of 4, I had minus 2 to the power of 14. Can I look at that and know whether or not the answer is positive or negative? Right? And again, it gives me one more opportunity to explain something about mathematical rules. Because while most rules in the situation where they are easy to demonstrate, you can demonstrate it using small quantities, 2 and 3 and 4 and 5 and things. As the quantities become larger, you would find that the simple processes that you use to understand what's going on when you're only dealing with 2 or 3 or 4 or 5, those processes become onerous, overbearing when you're talking about 14 or 25 or 56 or 79 and we ain't crossed 100 yet, right? So in other words, we usually have to figure out some system whereby we could know what is going to happen without having to consider every single minute possibility. We check the pattern, we see certain inputs, we see certain entities, and we know immediately what is going to happen. That is maths. And that is a process that many times we transplant into other areas of life, where we had to put some particular system together that would deliver a result that we could predict, that would deliver a result that we could understand, even when the inputs that go into the production of that result are many and varied and complex. Right? Yeah, things don't stay simple all the time, you know. Sometimes the things get complicated, and we have to figure out ways to understand the thing as it gets more complex. Right? So minus 2 to the power of 9, positive or negative? Without going into the details, we know that the answer is negative. Right? Minus 2 to the power of 14, positive or negative? Without going into the details, we know that the answer is positive. If you want to double check, check your calculator. 2 to the power of 9 minus 2 to the power of 9 is 2 to the power of 10 is 1024. So 2 to the power of 9 is 512. Let me just double check and make sure. Right? 2 to the power of 9 2 to the power of 9 is equal to, boom, 512. 2 to the power of minus 2 to the power of 9 is minus 512. Check your calculator and see. Right? Let me make a proper 5 now, man. That's looking a little better. I'm looking more 5-ish or 5-esque. 2 to the power of 14 is, let me see, 2 to the power of 14 is, boom, 16,384. So minus 2 to the power of 14 is also 16,384. Which means then that we can apply a particular rule that I want to write down on the board. And it is something that you can investigate on your own. Having gone into some of the details of the multiplication of negative numbers, it now puts us in a position where we can make the following claims that you could then proceed to investigate on your own as a conscientious and as a curious student of the mathematics. If we have a negative number, and we raise that to an even power, then the answer will be positive. And on the flip side, if you have a negative number that you then proceed to raise to an odd power, then the answer would be negative. You could write it like that, right? I'll write it in a more shorthand notation, which you might want to take note of for the record. So the shorthand variant of this is to say that minus 1 to the power of 2n, 2n representing an even number, is greater than 0. Positive, right? You can check it out. You can use minus 1 as a base and you raise it to an even power, even being 2n. 2, 4, 6, 8 going down the road. That is positive. And in like manner, minus 1 to the power of 2n plus 1 is less than 0. Which is to say that when you take the number minus 1 and you raise it to an odd power, 2n plus 1, 3, 5, 7 going down the road, that answer is less than 0, meaning that that is negative. Alright? So I'll give you the words and I'll give you the symbols, the numbers. Take note of both of them and check it out on your own. Play with it a little bit. Check it on your calculator. Just come up with random combinations. 3 to the power of 4 minus 5 to the power of, 3 to the power of 4 minus 5 to the power of 6 minus 5 to the power of 7, right? Minus 7 to the power of 3 minus 7 to the power of 4. Take a negative base, negative, negative. Apply the same logic to other negative numbers and see for yourself what happens in terms of the answer. Alright? So that is it for now. Right? So we went even further than we would have originally conceptualized at the beginning. Because at the beginning of this series, I was looking at multiplication, division, addition, and subtraction. Now we just do a whole video on exponentiation. That's how the maths is. It's nice. Alright, so stay in tune. We're going again. We have plenty more where it comes from. Yeah? Boom!